Hello everyone, welcome to Target45. Today we are going to solve prime number patterns. The moment you see these patterns, you can easily recognize that these are prime numbers. So this is the first pattern and this is the second pattern we are going to solve today. This is alternative step pattern. So let's understand this pattern. At first we need to understand what prime numbers is. Prime numbers are the numbers which has only two divisors, that is 1 and itself, then it is called a prime number. We have discussed this as part of day 2. If you have missed that, please kindly go back and watch that and come back to here. You can easily understand. The examples of prime number would be 2, 3, 5, 7, 11. So these are the examples of prime numbers. On a higher level, prime number definition is this. So let's get into it and let's solve it. If you want deep explanation of prime number, go back to day 2 and watch that and come back to here. You can easily understand. So let's define a function is prime. Here we are going to find if a number is prime number. So for this, if a number is less than 2, then we have to return false because it is not a prime number. For numbers in range of 2 to the square root of the number, we have to check if that number is divisible by I. If it is divisible, then we have to return false because it is simply not a prime number. Otherwise, we have to return true because if all of these conditions have failed, then it is simply a prime number. So this is the function to find out if a number is prime or not. We have discussed everything about this in depth in day 2 session. Go back and watch that and come back to here if you don't know what prime number is. So let's solve the first pattern now. For the first pattern, we need to initialize two variables, count and number to 0, count to 0 and number to 2. We are using while loop here. So we have to write a condition such that since we have 5 rows, for that 5 rows we are checking if count is less than 5. If is underscore prime, we are passing number to this is prime function and checking if this number is a prime number. If it is a prime number, print. We already know if we want to print the number in this format, we need to convert that number into string and then multiply it with the same number. Then what happens, this string will be printed this many number of times, this number times. So that is why we are writing like that. Now we have to increment count equal to count plus 1 because we are checking the while condition here. So when we get one number, we have to increment the count. In the same way, when it reaches to the 5, it will stop. And once this condition is satisfied, even if it is satisfied, if it's not satisfied, we have to increment number because we have to check it for multiple numbers. That is why we have to increment this number every time after this if condition. If this condition is satisfied, count will also increase. Even if this condition satisfied or not satisfied, this number will be increased. So let's see if we get the first pattern. If you see, we get the first pattern. So this is how we used is prime function and we are passing number as a parameter to is prime function. and this is a block of code which only runs when it is called. So this is how we solve first pattern using while loop here. Now let's solve the second pattern, which is this. For this pattern we are using the isPrime function. For this we need to initialize count to 0 and number to 2, and again for this we are using while loop. We are checking if count is less than 10. Since we have 10 rows here, if you see this, we have 10 rows, and based on the index it is printing positive and negative. Based on the index it is printing as positive and negative. When the index is positive it is printing as positive, and when the index is negative it is printing as negative. So for this we need to check if the number is prime first, because it is printing the prime numbers. First condition is checking the prime number, and the second one is if the index is positive then the number is positive. If the index is negative then the prime number has to be given the negative sign. So let's solve this. If is prime function, we are passing number here as a parameter, and if this count modulo division 2 equal to 0, since we need to check the index we are using this count. So if this count modulo division 2 is equal to 0, we have to print the number, otherwise we have to print it as negative. If you see, first we are checking the is prime condition here. Once this is satisfied, if it is even index it is printing as positive, if it is odd it is printing as negative. We know that we have to increment the number even if this condition satisfied or not satisfied. That is why we are incrementing the number here. Let's see if we get the pattern we are expecting for. Okay, we have not, okay, we did a mistake. We have not increased the count of the count variable, so let's increment it. We need to check this while condition, otherwise it will go to infinite loop. That is why it is important for while loop to check the condition, otherwise it can go to infinite loop. Just now we have seen how it went. See, this is how we wanted this and we got this. That's it. And if you see, we have used this function is prime function, which is a reusable code. So that is why functions are good for reusability. We have reused this code, this function, for both the patterns. That is how it is reusable. It is modular. Functions are modular. They support modularity because we are breaking complex problem into small pieces, small piece of code. And it also supports abstraction. Functions support abstraction, modularity, reusability. How abstraction? It hides the complex logic behind a simple function call. Simple function call. Making the code easier to understand. If you see, like, we are not writing the is prime function, is prime code condition here. Instead we are simply using the function with the function call by passing the number as a parameter every time. So that is how this code is helping us with reusability, modularity, and abstraction. And we are also avoiding the repetition. How the repetition? We are not writing is prime for every pattern. Instead, we have written the is prime condition at one place, and we are using this function through the function call. So this is how it is important to understand how functions are useful. Function is not just a block of code which runs the code when it is called, but also it helps us in reusability, modularity, abstraction, and it helps in avoiding the repetition. So that's it for today. If you have any doubts, please comment in the comment section. We'll try to understand and solve the problem. If you still have not subscribed to Target 45, subscribe to Target 45 because we are going to solve these kind of problems every day. And these problems are helpful for you for interviews, logical thinking, and competitive exams. That's it for today. Thank you.